Welcome to today's video on learning about forces and energy with Legos. First and foremost, a force is a push or a pull on an object caused by an interaction with another object. With our Legos, we apply a force to the Lego when we swing the gymnast. Now let's get a brief understanding of energy. There are two main types of energy, being potential and kinetic energy. Potential energy is the stored energy in an object when you lift it to a greater height. Kinetic energy, on the other hand, is the energy of an object that is in motion once the potential energy has been released. Before we start learning about forces, let's consider what we have right now. Currently, our Lego is at rest, and no forces are causing it to move left or right. Now, as of now, you can see that the levers are set pointing in opposite directions. This means that the Lego is stopping the wheel from moving due to the groove here. And so when I flip the gymnast, like so, there will be little to no movement, and the movement will quickly stop because the wheels are being blocked by these little components that get stuck in the grooves of the wheel. Now let's say I move this back piece, I flip it, and this way we only have one component pointing this direction, and no groove is stopping this wheel. Now, when I rotate our gymnast, you can see the movement. Let's do it the other way. I'll move our Lego to the side so we have plenty of room to move. I'll flip the toggles and let the gymnast spin. Now you observe the Lego moving in the opposite direction. Let's understand how this movement is happening. When we lift the gymnast like this, we're increasing the potential energy. As of now, there's no visible movement, so there's no kinetic energy. But there is potential energy because once we let go of the gymnast, like so, movement will be created and the potential energy will be transferred into motion. So again, this is increasing the potential energy, and when we let go of the gymnast, the energy is transformed into kinetic energy. Now what if we move the gymnast only part way up? This time, we'll have less potential energy, and so when we let go, the car will move less. On the contrary, if we lift the gymnast to the very top and then let go, there's greater potential energy, so more energy will be converted into kinetic energy, and the car will move further. You'll notice, the higher you lift up your gymnast, the more your Lego moves, as you have more potential energy that's being converted into kinetic energy. But the lower you lift the gymnast, the less your Lego will move. Due to inertia, an object at rest stays at rest unless acted on by an external force. That's why our Lego is currently stable and stationary until we create an external force by lifting up the gymnast and letting go. Now in my case, there's a limited amount of space that the Lego can move due to the size of my table. But now it's your turn. Use a large surface and then compare lifting the gymnast all the way up, halfway, and lower, and see the difference of how much your Lego moves. Get creative as you experiment, and I hope you learned a little bit about forces today. Thanks for watching, and I'll catch you in the next one.